Greetings and welcome to GILFORD'S lectures. So today we are going to be looking at the MIA Engineering Welcome Physics Test, and it's important to note that this Welcome Physics Test consisted of 15 MCQ questions in the section A and 3 essay questions in the section B. In this video we are going to be looking at the solutions to the first 5 MCQ questions in the section A, and in the subsequent videos we are going to be looking at the solutions to the other MCQ questions and the essay questions. So the very first question on the paper read: an object falls freely from rest. The speed v is measured at the depth h1 meter as v1 and h2 meter as v2. What is the relationship between v1 and v2 given that h1 is equal to half h2? So it's important for you to always note the topic of reference when you are solving any question. So the topic of reference for this particular question is mechanics, and in case you don't have knowledge on mechanics of a particle, then you may not be able to solve this question appropriately. Having knowledge on mechanics of a particle is paramount, or is important for you to solve the question properly. So this is the object falling from rest and hence has a velocity of v equals 0 meter per second. So the velocity at the height h1 is measured as v1, and at the height h2 which is measured as, observe that h1 is equals to half h2, hence h2 is equals to 2h1. That is, h2 is twice the distance of h1. That is why, or that is the inspiration from where we got h2 to be equals to 2h1, and drawing it such that h2 is the distance met when the object has fallen through the height 2h1 to the ground. So now, in an effort to go through the solutions of our problem, it's important for you to know that generally for rectilinear motion, v squared is equals to u squared plus 2gh, where v squared is the final velocity of the particle, u squared the initial velocity of the particle, g is the acceleration due to gravity, and h the height through which the particle is falling. So since we're given two velocities, we are going to analyze our motion in two stretches. For the first stretch of motion, v1 squared is equals to u1 squared plus 2gh1, and for the second stretch of motion, v2 squared is equals to u2 squared plus 2gh2. Remember that u1 squared is equal to u2 squared and is equal to 0 meter per second since the object was dropped from rest, and hence we are going to obtain v1 squared to be equals to 2gh1 and v2 squared to be equals to 2gh2. We now divide equation 3 by 4 and we are going to obtain v1 squared on v2 squared to be equals to h1 on h2. But remember that h2 was equals to 2h1, and hence v1 is equal to v2 on root 2 when we make v1 subject of formula in this expression. Hence, we can conclude that the option B is the correct option. So now, let us look at the question 2, which reads: in experience of Young's slit experiment, we are given wavelength equals 0.6 micrometer, screen-slit separation equals 1 meter, slit separation equals 1 millimeter. The distance between two fringes is. So in this question, you are asked to find the distance between two fringes in the Young's double slit experiment, or the Young's slit experiment. So as I've always said, when given any question, it's important for you to recall the topic of reference. So this question is drawn from wave phenomena, particularly in Young's double slit experiment. So if you have a monochromatic light source placed in front of a double slit as such, and a screen placed at some distance away from the slit, then a system of dark and bright fringes will be formed on the screen, such that the distance between the two fringes will be equal to x and will be equal to lambda, which is the wavelength of the monochromatic light source, capital D on little d, where little d is the slit separation and capital D is the screen slit separation. So now, diving into our calculations, we notice that the wavelength lambda was given as 0.6 micrometer, which is equivalent to 0.6 times 10 to the negative 6 meter. The screen slit separation is equal to 1 meter. The slit separation is equal to D, which is equal to 1 millimeter. And 1 millimeter is equivalent to 1 times 10 to the negative 3 meter. And hence the fringe separation x, which is equal to lambda, the wavelength of the light, times capital D, which is the screen slit separation, on little d, which is the slit separation, must be equal to 0.6 millimeter. Hence, we can conclude that the option D is the correct option. So now our next question is the question 3, and the question 3 reads, an electric motor alimented by direct voltage of 400 volt absorbs a power of 7,200 watt. The intensity of the electric current through the motor is. So as I've always said, it's always important for you to note the topic of reference or have the topic of reference at the back of your mind. So this type of questions are drawn from the topic electricity, particularly under DC circuit. So now the very first thing for you to know here is that generally electric power is the time rate of change of electrical energy and mathematically given as P equals capital E on T. Electrical energy is equal to V cure, where V is the voltage and cure is the charge. And so when we replace V cure in the expression P equals E on T, that is V cure for E, we obtain P to be equal to V cure on T. But cure on T is equal to I, that is electric current. Since electric current is the time rate of change of charge, hence P is equal to IV. We're given the direct voltage as 400 volt and the power absorbed as 7,200 watt. If we therefore make I subject of formula in this expression, we obtain I to be equal to P on V, and hence our I becomes 18 amperes. So we can conclude that the option B is the correct option. So now let us look at the question 4, which reads, having known the characteristics of this motor is rectilinear in the domain of functioning considered, and that the internal resistance is 2.4 ohm, the electromotive force is. So now in this question they are talking about an electric motor you already know of. Actually, it's the same electric motor that was mentioned in the question 3, and hence we can conclude that the question 3 is related to the question 4. So we'll be using the physical quantities mentioned in the question 3 to solve the question 4. So now let us revise, let us have some brief revision on what the electromotive force is and how it is being calculated, because we are going to be needing the formula for the electromotive force to be able to solve this question appropriately. So if you have a circuit as such, where a battery is represented in this green box, then it's important for you to note that when no current is being drawn from this battery, the potential difference across the ends of this battery is known as the electromotive force and is the maximum potential difference when no current is drawn from the battery. It's also important for you to know that all batteries offer some amount of resistance to the flow of current because of the chemical constituents that make up that battery. So the chemical constituents making up a battery offer resistance to the flow of current, and so we can always say that all batteries offer some amount of internal resistance to the flow of current. So we can therefore have a resultant circuit where the EMF of the battery is shown, the internal resistance of the battery is shown, and we connect a resistor in the circuit such that a current I is drawn from the battery. Hence, according to Kirchhoff voltage law, we can conclude that epsilon is equal to V plus IR. So now recall that the direct voltage was equal to 400 volt, the electric current was equal to 18 ampere, the internal resistance was equal to 2.4 ohm. And from the fact that epsilon, which is the EMF, is equal to V plus IR, we can do our replacement and conclude that epsilon is equal to 443.8 volt. Hence, we can conclude that B is the correct option. So now, let us move to the question 5, which reads, the heat released by the Joule effect by the motor during a day of functioning is. Recall that the heat released by Joule effect is given by P equals I squared R, where R is the internal resistance and was given by 2.4 ohm. I is the electric current given by 18 ampere, and we'll do our replacement to obtain P to be equal to 777.6 joules. Hence, we conclude that the option C is the correct option.